On the shark bite, are there any questions we want to go over? Elijah, either go back to your seat or sit by Allison. Were there any questions on the shark bite we wanted to go over? Aaron. Okay, so we'll do those 4 and then we'll talk about today and previous. Okay, for number 1, this is multiplying binomials. So you're going to FOIL or distribute twice, multiply the first and the outer, the inner, and the last. So 6x times negative 2x, multiply the actual numbers together, and then the exponents, you would add them. They both have an exponent of 1. Then the next one, 6x times 3, would be plus 18x. Negative 5x times negative 2x is positive 10x. And negative 5 times negative 3 is negative 2. And then you would combine like terms. So negative 12x squared plus 28x minus 15 will be that final answer. Questions on that one? Right. For number 4, you were given a graph, so there were a couple different ways you could have done this. One, using the graph. If we plotted the point for negative 1, and use the slope negative 3 over 2, so go down 3, to the left 2, negative, up 3, to the left 2, and keep doing that. You would eventually run into the y-axis. Then you have your slope, you have your y-intercept, and you could write that in the equation. Y equals negative 3 over 2x plus 5. You could have also used your point slope formula. We're not going to talk about that today, but you could have also done that. Questions on that? Alright. As I mentioned last class, we have one last unit to get through. It's 2 objectives, so what we're going to do today, and we'll learn the rest on Friday. For the second objective, we are not testing this one officially. It will be tested on the final, though. I did pass out final exam reviews for you to start working on practicing. The answer key is on Canvas. Next week, we will start officially going through all of those things, going through the review and asking questions. Some specific dates you need to be reminded of. Yesterday was the deadline for the first 2 objectives on the Unit 9 test, so if you did not finish those are no longer being replaced. They will still go in marking period 4, but no longer replacing those grades. Tomorrow is the deadline for 9.3 and 9.4, so make sure you get those done. After we do notes, you'll have time to work on that. The last objectives will be next week. All retakes and missing work is due by the 8th of June. So that seems far away, but it's not that far away. So make sure you have your work done, retakes done, all those things. Questions on any of those? So let's start with this. Those of you going on to Algebra 2, this is the first thing they talk about. So you'll be like relearning this, but in more depth in August or September. So fill out this first part. So the steps to solve an absolute value equation. 1, make sure the absolute value expression is isolated. So the absolute value bars have to be by themselves. 2, set the inside equal to both the positive and negative number from the other side of the equation. We'll talk more about that when we see it. 3, solve both equations. And then 4, write your answer as a solution set. That part isn't really new because we did that in quadratics, but we're going to be doing that again. Anyone still writing that part? So I have specific examples that I want to go through, and then we can go through any you guys want to go through, and then a couple Khan Academy examples, and then you guys will have time to work on retest stuff, finish tests, work on review, Khan Academy, stuff like that. So number 1, we would first have to isolate it, but it's already isolated. There's nothing outside of the absolute value bars. So then there's nothing to solve really. Then you would set the inside equal to both a positive and negative version of whatever it equals. Remember that absolute value measures distance. So that distance can be positive and negative, which is why we do both. If these were actual equations, we would solve them, but we don't have anything to solve, so those would be our answers. You can write it least to greatest, or since they're the same numbers, plus or minus 2. Do we have any questions so far? So this would be like at the end, more so. We're going to do number 4. So 4, same thing. You would isolate the absolute value bars, but there's nothing outside of them. So set the inside, drop the absolute value bars, and set the inside equal to a positive 28 and a negative 28. And then you're going to solve both equations. We would divide both sides by -7. So that A equals a -4 and a +4. So again, you could write them separately, the curly brackets -4, 4, or altogether +/-4. They won't all be like that, but if you don't add or subtract anything, they'll all be like that. Questions so far? We're going to skip down to number 7. Again, the absolute value bars are already isolated, so there's nothing we need to do there. Set the inside equal to positive 34 and negative 34. And solve both equations. Subtract 2. We have 4n equals 32 and 4n equals -36. Divide everything by 4. So this would be a case where you have two different numbers, because we have 8 and -9. So then we would list that n equals, curly brackets, -9, 8. What questions do we have so far? Once you finish writing that, and if you don't have questions, you can go on to the next page. we've done so far didn't have things outside the absolute value bars. These will. So as we were saying, or as I was saying before, isolate the absolute value bars. So you would solve it like a regular equation, leaving whatever's inside the absolute value alone until later. We're going to start with 12. So we have a -2 on the outside of the absolute value bars. So to get rid of that, we would divide both sides by -2. Notice that I'm keeping the absolute value bars until it's completely isolated. Then, once it's isolated, then I can drop them, set it equal to a +7 and a -7. And then we would solve both. Subtract 3. We have z equals 4 and z equals -10. So in your curly brackets, -10, 4. Have any questions about that process? And then we're going to do 14, and we have two things outside of the absolute value bars, the -10 and the -3. Which do you think we're going to do something with first? -3. I'm going to get rid of that. Add it to the other side. Then this problem is now just like the last one we did. So divide both sides by -10. Now the absolute value bars are isolated, so we can drop them and set it equal to 8 and -8. And subtract 5 on both sides. So h equals 3 and h equals -13. Let me put this answer over here. So this would be h equals, curly brackets, -13, 3.
Doesn't matter how you place the number 13 and 3.
In here?
3. Doesn't matter.
It has to be least to greatest. So yes, it matters. The last two examples I want to show you are 17 and 18. All the examples we've done, once you've isolated the absolute value bars, it equaled a positive number. If it equals a negative number, we cannot solve it. There's no solution. Since the absolute value measures distance can't be negative. So if it's isolated, the absolute value bars, and we've already solved everything, and it still equals a negative, we cannot solve it. Sometimes you'll get things that look like we're going to be able to solve it, but then it changes as we're isolating. So like this one, I would divide both sides by -3. And as we isolated it, it became a negative. And because of that, we can no longer solve it. The opposite is true as well. Sometimes it'll look like it won't be able to be solved, and then once you isolate it, the negative goes away. So you can't decide until it's isolated completely. once you write that down, go back through all the examples we skipped over and find any you want to see do go over review. 13. Absolute value cannot equal a negative number when isolated. So we'll have time to do 13, but not 16. We'll do that one when we come back. 13, if we have to isolate the absolute value, what would we do with the 6? Multiply both sides by 6. Then it's isolated, so you can drop the absolute value bar, set it equal to positive 18 and negative 18. Add 4 to both sides. So 22 and negative 14. And divide all sides by 2. So our two answers would be negative 7 and 11. If you have questions about that one, we'll discuss that when we come back from lunch. Before we move on to 16, did we have any questions about 13? Or if you didn't finish writing it down, make sure you get that down. For 16, what do we think the first step would be? You have 3 over 2 times the absolute value of 4r minus 4 equals 3. So it was a negative, then it changed to a positive. To get rid of the 3 halves, flip it. Multiply both sides by 2/3. And then what would be left would be the absolute value of 4r minus 4 and equals 2. Then we could drop the absolute value bars and set it equal to 2 and negative 2. And solve both. We have 4r equals 6 and 4r equals negative 2. Sorry, just 2. Divide both sides by 4. We're going to end up with fractions. R equals curly brackets. If we simplify both, 1/2 and 3/2. Questions on that one? Any other questions we want to go over? See, do. If not, turn your notes over to the back and write this down. Say space them out. So this is negative 2 times the absolute value of x minus 14 plus 5 equals negative 6 times the absolute value of x minus 14 minus 1. write this on the back. So these will be examples that you'll see on the Khan Academy that's due on next Friday, not this coming Friday. And what's different between this and what we did is that you'll see two sets of absolute value on both sides. In order to solve this, you'll have to get one of those to the other side. Think about it like when you move x's or combining like terms across sides. This is kind of the same thing. So the negative 2 is like connected to the absolute value, the negative 6 is connected to the absolute value. So we can either add 2 times the absolute value of x minus 14 or add 6. Does not matter which one. So let's say we add 6. And we're just adding that piece, the negative 1 stays the same. And the negative 5 stays the same. When we add that over, we're only combining the numbers. We are not combining what's inside. That just gets brought down.
So it's kind of like if you had a single variable that was the same, we're just combining the terms. Basically, yeah.
Because then once you do that, one of them goes away and you have just one absolute value equation that you can solve that looks more like what we were just doing. So subtract 5 on both sides. And divide both sides by 4. Can we keep going with this one? It's negative, so because of that, we can't keep going. It's no solution. We stop. Do we have any questions on that one before we try the next one? For the other example, same process. We're trying to combine this and this together. It does not matter how you do that. So let's say I move 7 times the absolute value of x plus 1 over. Then we have negative 5 equals 9 times the absolute value of x plus 1 minus 5. And we would isolate the absolute value, add 5 on both sides. But what happens when we do that? What would this become? 0. So after we finish isolating, so divide this by 9, and it'll still be 0. When we go to set it equal to a positive and negative, there's no such thing as a positive 0 and negative 0, so you're just going to set it equal to 0, and that's it. And solve for x. So really with all absolute value equations, you're either going to get 2 answers because of the positive and negative, 1 answer because it got set equal to 0, or no solution. What questions do we have on that? Then for the remainder of class, you guys can work on this Khan Academy, your final exam review that's on your desk, more of these problems on the notes, finishing your tests, working on retake work, any of those things. Remember that I am not staying after if you're not using this time wisely, so make sure you're using this time wisely. If you want to finish your test, you can put your phone up and come see me. If you want to work on retake work, you can come see me. I need to keep putting in grades, so if you have questions about any work, you can also come see me to do that. Use this time wisely.